Hello everyone. I finally got on the air here. This is KP the Math G. Back with you another video. This is the 2012 free response question number 2. Yeah, it is not drawn to scale at all, but I wanted you to see a big picture here. Okay. This function is ln of x. This function is y is equal to 5 minus x. And this region is region R. Okay. 3 quick questions, so we're going to see if we can do that. We want to find, first of all, we want to do is, let's find, alright, so we're going to find the area. Alright. Now, I again emphasize on this that when you are trying to find an area of R, then it is imperative that you find out how to find this point of intersection. It's important that you get both the x and the y on this one. I mean, you could possibly get away with the x for a while, but eventually you are going to need the y value as well. So there are 2 ways to find this area. Let me see, this is region R. Okay. So one thing you can do is that you can, and I'm just going to set them up, okay? You can find the area from here to this point. Now you got to remember, if you're going to do it this way, you got this, you might want to call this region 1 and this region 2, and you got to add up the 2 regions. Okay, you could do it that way. That's one way to do it. Okay, like that. Okay, and find this region in here. But the deal is where to go from. We know to start from 1, but what is this x value here? Okay, what is that x value right there? So we got to go from 1 to whatever this x value is. Alright, and of course we're dealing primarily here with this curve, which is ln of x. So ln of x dx. In addition to that, you are going from this x to 5. Alright, so x to 5. Alright, maybe we call it x of 1, okay, whatever. Well, we got to figure out, oh, by the way, this is 5 minus x dx. If you want to do it that way, you're welcome to do that, but now we got to find where they intersect. So once again, to be able to do that, you have to go to y equals, and you have to put those into, I got y sub 0, y sub 1, you probably have y sub 1 and y sub 2, I don't know. It doesn't matter which one you put in, but then you need to graph that. And when you do, you'll find this line of intersection. Okay, you have to be aware that you're looking for, oh, I don't know if you can see that or not, but there is a line of intersection there. Okay, a point of intersection, a line, or in this case a point of intersection. Okay, so you want to intersect, and when I hit the word intersect, my numbers come straight up from there. Alright, so in this case, the x value is, this x value that we're looking for, alright, so the x value is 3.6 something, 3.69344, and then the y value, which we're not interested in on this particular problem here, this one here, but maybe you might need it, is 1 point, let's see, 1.306. That may be enough, but I'm just going to go on out 5, 6. Okay. Alright, so that, my little grandson Levi's in the way, but that's alright. This is my X value, this is my Y value. So we'll make this X1, make this Y1. So in this case, we would just simply put that in 3.69344 right here and right here. Okay, I'll just have to erase some of that now. 3.69344. Now I've done videos like this before, but you do need to be aware of this. This test is upcoming real soon. I guess, I don't know. I have to check and see when that 2024 AP exam is. I can look that up, but I'm not going to look it up right now. Okay. Alright, so that's really what you can do. But you have to remember, this side is the ln function, this side is the line function. So you just got to remember, this is going from 1, not from 0, but from 1. Okay. Alright. And then from here, the rest of the way over is 5. So that's what you're doing here. Now that's one way to do it. Okay. And when you do that, I will tell you what you get. Let's see here. When I do that, I get 2.9858. 2.985. So this is about equal to 2.985, and I think they round that up to, let's see, 2.9858. So that's going to make this 5 a 6, or you can leave it as, you can truncate it or leave it as that. Either way, that's what you're looking for there. Now that's one way to do it. That's just one method. Now what's the other? You don't have to have 2 integrands here. You don't have to have that. You don't have to keep it in terms of x if you don't want to. Maybe you would like to run your I subinterval this way. Alright, like this. Okay, let me show you. And instead of dividing that into 2 regions, we're just going to have one big region. Alright, like that. This is more or less review than anything, but I do want to make sure that you understand that. Okay, so let's see, that was 2.986. Alright, if you do it this way, you can go ahead and go this route here. Okay, have a nice subinterval coming this way. Now remember, when you're doing it this way, this value is x, this value is x as well. X of 2 minus this part, we don't want this part right here. So that's what you're doing here. You're always subtracting the furthest one to the right minus the one from the left. So in this case, it is this, but now you can't. This is x, so you got to solve for it. This is going along the x-axis here. This value is some x, and then this value is some x. So you have to solve for x. So in this case, where you have y is equal to 5 minus x, then solve for x. I would just like to bring the x over. So if I do that, plus x here, plus x here, alright, x over here. Alright, so now I've got x plus y is equal to 5, and then I can subtract the y on both sides. So now x is equal to 5 minus y. In the case of y is equal to ln of x, alright, y is equal to ln of x, then the e does that. That gets rid of your ln, and immediately you have x is equal to e to the y. Alright, so you have to do that first. If you're going to go this way, perpendicular to the y-axis, you've got to take this whole x minus this x right here. X of 2 right here if you want, minus x of 1 right here. Okay, you don't want this part right here. That's why you're subtracting it off. So what you're having as an interval is, let's see if I can put it down here. Well, I don't know where to put this. Let's see. I can put it right over here. Okay. Alright. Now, let's see here. Let's use this color. Maybe we can use red. Okay. Alright, now I've got to watch what I'm integrating from here in this case. Think about it right here. I'm integrating from 0, okay, x equals 0 to ever how far this y value is right here. Well, the y value is 1.30. Okay, so, alright, so in other words, you're going from 0 to 1.30656. That's a 0 right there. Now you are subtracting off the right side. Even if you don't remember it's the right minus the left. Alright, so the right side is 5 minus x minus e to the y. Don't make a mistake and say ln of x like I did when I was practicing this. E to the y dy. It's important that you get your numbers, your integrand numbers correct. You cannot say 3.69. This is going on the y. See, up and down the y. Alright, how high up or how low can you go? 0. How high up can you go? Well, to 1.30656. It's just a little important that you understand that, but either way, you are going to get the same answer. So when I plug that in, I will get, of course, 2.985 or 2.986, either way. Alright, so in this case, this area equals 2.986. Alright, that would probably be in square units, but it doesn't have any units here, so this is just all we're getting here. Alright, that's mainly what I wanted to show you on that one. There is a part B and a part C that perhaps maybe I'd like to show you. Let me do that in another video. I would like to kind of do that in another video, but this is mainly what I wanted to show you. Yeah, because that's not going to take that long. I just mainly wanted to show you this right here. Two ways. If you wanted to go perpendicular to the x-axis, you had to take in consideration how far this x value here. So from 1 to this value, and then from this value to 5. Okay, and then 1 to this value here is pertaining to ln. The rest of the way is pertaining to this line here. If you didn't want to do that into two parts, you could solve for y and do it in one interval like this. But you got to remember, this is the y that you're putting up now. Okay, from 0 to this y here. Okay, you just got to look and see which way, how far that isomorph interval can go. Okay, it can go from 0 up to here, and so that's the idea behind this one. And I'll take time to do the other two videos. You know, these won't take too long to set up and do. And anyway, I have to know what that. Well, I'd have to keep that answer to A to be able to do C. So anyway, I'm just going to let it be like that. Alright, this is KP the Math G. Make sure you subscribe if you haven't already, unless you just don't want to subscribe, but I'd like to encourage you to subscribe if you would. And make a comment if you will, and hit that like button. So anyway, KP the Math G signing off. Ladies and gentlemen, you have a great day. Now let's do that again. That wasn't loud enough. Ladies and gentlemen, have a great day. Ow. Okay, that was much better.